Runtime verification with logic labeled finite state machines. Demonstration. Traffic signals managing a crossing.
Version 1. North-south direction is green for 30 seconds. Then, it turns amber for 5 seconds.
Signals alternate. East-west is green for 30 seconds, and it is followed by amber for 5 seconds.
Software components.
The first element is a timer constructed as a logic-labeled finite state machine. Layer 2 are the 4 wrappers to the declarative description of when to switch lights. The specification of both versions is a prologue program. We compile the wrappers, and each will run in a separate thread, inspecting the middle way for its inputs and placing back an answer in the whiteboard when they reach their conclusion. The east-west controller is also a logic-labeled finite state machine. Its structure is a loop of 3 states. The state where east-west signal is set to red. The state where east-west direction is green. The state where east-west only light on is amber. The north-south controller is a logic-labeled finite state machine as well. It is analogous to the east-west controller. Although all 6 lights are controlled independently, it also cycles through setting on either the red, the green or the amber. The 4 wrappers are started first in this accelerated display of the simulation. They answer the logic expression in the transitions of the controllers. 2 wrappers answer the when at the turn for east-west to turn red, and when to turn amber, while the other 2 answer when shall north-south turn red or amber, east-west turns green when north-south turns red, and vice versa. The top left window shows the concurrent execution of the 2 directional controllers, with the deterministic schedule central to logic-labeled finite state machines.
The entire system is unmodified for version 2, only the prologue program changes.
2 wrappers out of the 4 now work differently. So the trace of execution is not cluttered. We place the timer in another thread, but it can be part of the sequential schedule of the controllers. Where there is no car on the east-west direction, the north-south can remain green beyond 30 seconds. But even if there is traffic in the east-west direction, its turn is limited to 30 seconds. The north-south cannot stop the east-west traffic and sensing waiting cars. The north-south also times out at 30 seconds. Lack of traffic in the east-west direction causes an early switch to green for the north-south direction.
How do we incorporate runtime verification?
We add a subsumption switch, and safety properties can be verified by a monitor. The switch is a subsumption switch but also implemented as a logic-labeled finite state machine. First, monitors can inhibit the output of the lower layers and replace it with newer, safer output. Second, monitors can send new input to lower machines to steer them away from trouble, or suspend them and restart them. Third, monitors can completely reconfigure the arrangement by unloading some LLFSMs and loading replacements.
A faulty software may place signals for both directions on green.
The monitor tracks the states of the controllers and tests whether those LLFSMs are both in their state of indicating green. Such fault triggers loading a new logic-labeled finite state machine. The new behavior has higher priority in the subsumption architecture, and places both directions into a pattern of blinking on amber. After 10 seconds, the previous behaviors are removed, and default behaviors are loaded while still running.
To demonstrate the runtime verification and correction, we compile all LLFSMs. They are not interpreted.
Besides the 4 wrappers, we see the subsumption switch starting. We launch the timer in another thread just to track the others' LLFSMs. In the accelerated simulation, we reach the point both controllers set their lights to green. the commands from the blinking LLFSM take over for 10 seconds. After loading correct controllers, the behaviors is correct. The architecture shows the system is self-correcting while executing. We can go back and inspect the loading of new behaviors and the suspending the blinking behavior.